Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're going to find the nth term of a quadratic sequence. Just to give you a flavour of what we're doing, let's start by reminding ourselves how to work out the nth term of a linear sequence. Pause the video and double check you can remember how to do that. Okay, you should have realised that this linear sequence was going up by a common difference of 3, and you use that in order to get you the nth term is 3n add 1. If you're not sure about that, you must go back to your building blocks. Now, what's the point of this video? Well, below is actually a quadratic sequence. And in this quadratic sequence, we want to find the nth term as well. Now, when we work through this, we realized in the previous video that when you have a quadratic sequence, the second difference is constant. Let me prove that for you now. And that's going to be the key in order to find a formula for the nth term of a quadratic sequence. Now, one more thing to think about before I show you what the nth term is. If I asked you what the general form of a quadratic expression is, what would you say that is? Well, usually we've thought of it in the past as something like ax squared plus bx plus c. That's a general quadratic in terms of x squared. But if we're dealing with the nth term of a quadratic sequence, it's going to be in terms of n's. So we're going to be looking for something of the form an squared plus bn plus c. So our nth term is going to look something like that. The reason that's quadratic, the highest power of n is n squared, and there may be n's, there may be numbers, there may or may not be those, but you certainly will have some amounts of n squared. So when we find the nth term of a quadratic sequence, it will look something like this. For an a we need to find, for a b we need to find, and for some c we need to find. Now let me show you the theorem. So the theorem says that when we are trying to work out the nth term of a quadratic sequence, as I've just said, it will always be of the form some lots of n squared, some lots of n, and a number, i.e. an squared plus bn plus c, where we have to find a, b, and c, right? But a, b, and c will always satisfy the following equations, and these are the equations you're going to use to find a, b, and c. It is always true that two lots of a give you the second difference in the sequence. That second difference that is always constant. 2a is always equal to that second difference. It is also always true that 3a add b is always equal to the second term of the sequence subtract the first term of the sequence. That always holds. And lastly, it is always true that a add b add c gives you the first term of the sequence. And we are going to use that in order to find the nth term of a quadratic sequence. Now, it's a bit cheeky of me just to put this up there and expect you to just take my word for it. I'm actually going to show it to you and why this is true. You may or may not need to know why this is true, but I think it's good mathematical practice to always understand where these things come from. So it's going to take me a couple of minutes to explain why this is true. Let's have a go. Here's the proof. Suppose I had a quadratic sequence and its nth term is of this form. I know that is always true because that's why it's quadratic, right? I'm going to write the first term, the second term, the third term, the fourth term in terms of a, b, and c. And this is how I'm going to do it. I'm going to substitute in n is equal to 1 to get me the first term. Let's think what we get. If I put 1 in for n, I will just get a plus b plus c, won't I? So the first term will always be a plus b plus c. If I put n is 2 in here, substitute in, think what you get. 2 squared is 4, so I get 4a. Put in n here, I get plus 2b, and I get still the plus c. If I put in 3 in here, think about it, I would get 9a plus 3b plus c, and if I put in 4 in here, I would get myself 16a plus 4b plus c. And they are the terms in terms of a, b, and c, right? Now, the first difference is what I get if I take the second term and take away the first term. So I'm going to do a subtraction here. Let's see if we can do this. I'm taking this and I'm subtracting this. So 4a take away 1a is 3a, right? 2b take away a b is plus b, and c take away c just eliminates the c. Let's do it here again. 9a take away 4a is 5a, 3b take away 2b is 1b, and c take away c gives you no c's. And let's do it again here. 16a take away 9a is 7a. 4b take away 3b is 1b. C take away C is nothing. And there we go. And lastly, let's go for this second difference. Let's subtract these two. 5a add b take away 3a add b. 5a take away 3a is 2a. B take away b is nothing. 7a plus b take away 5a plus b. 7a take away 5a is 2a. B take away b is nothing. And look, the magic has happened. 2a is always equal to the second difference. Remember, I told you that back here. Look here, I told you it was true that 2a always is the same as the second difference. See? Didn't I also tell you that the second term subtract the first term was 3a add b? Let's have a look. Didn't I say that? I did. I said the second term subtract the first term is always 3a add b. And lastly, didn't I always tell you that the first term here is always a add b add c? And indeed, that is what I wrote there. So, that is now a fact. I think I've shown that to you adequately. I think we're allowed to use it now. So let's do two questions at the end and try and find the nth term of a sequence. Here you go. Find the nth term of this sequence, assuming it's quadratic. I've written the rules we can use over here. Now, we're going to work out some of the differences. Let's start off by working out the first difference. That there is 7, this there is going to be 11, this here is going to be 15, and this here is going to be 55 subtract 36, which is going to be 19. The second difference is going to be constant. It's 4. That reminds us that is actually a quadratic. Now here's where we can use our rules. We know that 2a is always equal to the second difference. So we know that the nth term of this sequence is of the form an squared plus bn plus c, where we have to find a, b and c. So let's go off and find it. 2a is always the second difference. 2a must equal the second difference, which is 4. Dividing both sides by 2, I get myself therefore that a is 2. Found a. Great. I also know that 3a add b is equal to the second term subtract the first term. The second term is 10, subtract the first term is 3, was 7. It's this number here. So I know that 3a add b must equal 7. But remember, I know a now, so I can substitute that in. 3a, that's going to be 3 multiplied by 2, add b is equal to 7. That means that I've got 6 add b is equal to 7. Subtracting 6 off both sides, I've got b as 1. Okay, and there you go, I found b. And the last thing I need to do is find c. But I know the following. I'm just going to shift this up. I know for sure that a add b add c always gives me the first term, you see? And the first term was 3. Now, because of the work I've done above, I know a and I know b, so I can put them in. A is, remember, 2, b is 1, so 2 add 1 add c is equal to 3. 2 add 1 is 3, so 3 add c is equal to 3. Subtracting 3 off both sides, I get myself c must be 0. So, therefore, I have a formula for the nth term. Tn is an squared, well, I found a is 2, so it's 2n squared, plus bn, well, b is 1, so plus n, plus c, and c is 0. There you go, I have found the nth term of this quadratic. Okay, one more for you to try. Pause the video, have a go. Right, always start off with common differences. The first one here. So, that's going to be 7, that's going to be 13, that's going to be 19, and that there is 64, subtract 39, which is 25. Let's do the second difference and hope that it's common. So that's 6, and that's 6. Indeed it is. Therefore we know it is a quadratic. So we know the nth term is of the form an squared plus bn plus c. And we know the following is true. We know that 2a is always the second difference. So 2a must be equal to the second difference of 6. Dividing both sides by 2, a is therefore equal to 3. There's a. We also know that 3a plus b is the second term take away the first term, 7 take away 0, which is 7. So therefore 3a plus b must equal 7. Remember, I know a, so 3 multiplied by 3 plus b equals 7. That means 9 add b equals 7. Subtracting 9 off both sides, b is negative 2. And there you go, I've got myself b. The last thing we also know is that a plus b plus c is the first term. So therefore a plus b plus c is always the first term, which in this case is 0. I know a and b, that's therefore 3 add negative 2 add c equals 0. 3 add negative 2 is just like 3 take away 2 is 1. So this is 1 add c equals 0. Subtracting 1 off both sides, c is negative 1. And there you go, I have found everything I need. The nth term is therefore an squared, so 3n squared, plus bn, well b is negative 2, so negative 2n, and then add c, so add negative 1, i.e. subtract 1. And there you go, the nth term of this quadratic. And we're done. Thank you very much for watching.